Hi, this is Steve Piloff from George Mason. I want to talk to you about some relationships between the price of bonds, their value, with various characteristics. First one, I think pretty common sense. You got two bonds with the same yield to the same risk, same face value, same time to maturity, and same coupon payment schedule, which means they're basically going to be paying checks at the same point in time, and those cash flows from the bond have the same risk. However, they have different coupon rates. The one with the higher coupon rate has the higher value. So if I had two bonds and one was going to have one had a low coupon rate, so it was sending me checks for $10 for the next 5 years, and then $1,000, and one had a higher coupon rate of let's say 10%, so it was sending me $100. I'd rather get $100 every year than 10, so obviously a higher coupon rate has a higher value because you've made all else equal. You can draw a nice little picture that as the coupon rate goes up, basically the size of those checks go up, the price goes up. And again, it's all else equal, so these bonds, have the same face value. They're going to be paying. In this case, we're looking at a bond that has 10 years, same maturity, same yield to maturity, and they are going to pay at the same point in time. It's just, here this guy pays $200 a year, this guy pays $10 a year, and you can see getting $200 a year for 10 years makes that bond worth $1,600. When you're only getting $10 a year, it's worth only a little more than $400. Relationship 2. Basically, two bonds have the same expected cash flows. They have the same coupon rate, the same face value. So they're going to have the same coupons, same time to maturity, so they're going to be paying them to the same point in time, and at maturity they're going to pay the same face value, same coupon payment schedule, so there's no confusion. The checks all come at the same time, but they have different yields, different levels of risk. The bond with the higher yield, with the higher risk, has the lower value. Two ways to think about it. One, suppose I have two bonds. One is riskier than the other, so you've got these promised cash flows that are the same, one from a risky source, one from a safe source. Which one would you rather have? If I'm going to promise to pay you $100 a year for the next 5 years and then pay you also $1,000 in 5 years, would you want that promise coming from someone who's really risky or really safe? If it came from someone who was really, really risky, you would place less value on it. The other way to think about it is remember that the present value of a bond is just the present value of all the coupons all the way out to that last coupon plus par value, get your money at maturity. The higher R is, the greater the yield to maturity is. R is either yield to maturity or half yield to maturity. The more you're discounting those coupons and those payments, the lower the value. And so here you can see that when you have a very risky bond and the yield to maturity is 20%, then you're discounting all of those coupons, those $100 coupons from the 10% coupon rate by such a high rate that they don't have a lot of value, and the bond itself is only worth $500. If you have a really safe bond and the yield to maturity is only 1%, then you're not discounting all those coupons by very much. They're retaining a lot of their value, and the bond would be worth $3,000. So let's take a look at a few problems. You have two bonds, A and B. They have the same yield, the same face value, the same time to maturity, and the same coupon payment schedule. So they're going to be paying coupons at the same time for the same amount of time. And they have the same level of risk, but A has a coupon rate of 4% and B has a coupon rate of 6%. So A is going to pay you $40 a year and B is going to pay you $60 per year. What would you rather get? You'd rather get $60 per year, and so B is the one that's going to be more valuable. How about C and D? These guys are paying the same expected cash flows because they have the same coupon rate, same face value, same time to maturity, and the same coupon payment schedule. So for a certain amount of time, they're going to pay the same coupon, and then they're going to mature, and then they're going to pay the same face value. But C has a yield of 7%. D has a yield of 9%. So we know that C is safer. if we're going to have promised cash flows, we'd prefer them from the safer source, and so C. The other thing is, if these guys have the same coupon rate, the present value is going to be coupon, and C, you're always going to be dividing by 1.07, 1.07 squared, however long it is until it matures, as well as par value over 1.07 to however many periods that is. D, on the other hand, will be divided by 1.09 and 1.09 squared, and so it's a higher number that's on the denominator. As a result, less value for the bond. So now suppose the yield to maturity for C were to increase from 7% to 7.5%. What would immediately happen to the bond price? Well, we know that when the higher the, as we saw in this example, the higher the yield to maturity, the less the value. And so if this were to happen, the price would be expected to decline. So 1 minute you're dividing all of those cash flows or discounting them all by 7%. The next minute you're discounting them by 7.5%. Price would go down. Another way to think about it is 1 minute we think of it as a level of risk consistent with 7%. A minute later, the risk has gone up, so it's as evidenced by the fact that yield is now 7.5. It's riskier, less value.